we started about the quadrilateral functions, understanding about the quadrilaterals. So before starting the quadrilaterals, we have to do the some plane surface and the plane curve. Which thing is called plane surface?
Plane surface.
Yes.
When you join a number of points without lifting a pen paper.
If you have to give me the example of plane surface and the plane curves, what that will be? Examples of plane surface and plane curves.
Plane surface
And plane curves.
an example.
Yes, an example. Plane surface is something like that is like a flat. For example, the page of your book, that is a flat, that is a plane surface. Okay? Anything that is like a straight line, simplest form, like a circle, that is a plane surface. Okay? If we have a page, we cut that page in the direction of a circle. Okay? If we join two edges to circumference of a circle, that is known as a curve. That is a plane curve surface. Okay?
So a paper is an example
Of plane surface. If you just give a curves, if you just give a direction to that page, that will become a plane curve. Okay? So here are the few figures. In figures we have done this. Which type of these figures do have? This is the open curve, closed figure, simple closed curve, and the difficult one. Okay?
Okay, ma'am.
Okay. Now we have the polygons. Can you define what is polygons?
Two-dimensional shape with straight lines.
Very good. What are the examples of polygons and what are the non-example of polygons?
Examples can be triangle, quadrilateral, pentagon, hexagon, heptagon, and octagon. Non-example of polygons.
Like a circle is count in the polygon? Circle?
No.
No. And the open shapes, open curves?
Cone.
Cone. No. Cone can be counted in the polygons.
Cylinder.
Cylinder, I don't think so. Cylinder and cone will be counted in polygon example or non-example. As this is closed or open curves?
They are closed.
Closed. So cylinder and the cone are the non-examples because cylinder and cone are the 3D shapes and polygons only belong for 2D shapes. You have to remember that the curve that are close, the straight lines that are close, that is simply gone with the group of polygons. If we have any 3D shapes, that will be not counted in the polygons. If we have the
2D shapes,
3D shapes and the curves that are open, the lines that are open, that will not count in the polygons. Okay?
Yes, ma'am.
Good. Now we have done with the examples and the non-example of polygons. Draw a rough figure of polygon. Identify its sides and vertices. We have done with the sides and the vertices. How many sides do triangle have? 3. Quadrilateral, 4, penta, 5. We have done with this. Okay. How we can count the sides of any polygon? By counting the
Points.
points, corners of that diagram. Now the next is the most important thing. What is diagonals and how we can find and draw the diagonals? Diagonal is a line segment connecting two non-consecutive vertices. For example, if we have a polygon, let's see here. If we have a polygon, triangle is a polygon.
Yeah.
Yes, triangle is a polygon. So here is a polygon. These are the 3 sides that are non-consecutive. 3 sides are non-consecutive. Means they are not connected with each other. They are separate with each other. We have to join. We have to draw a line between these. For example, here one line segment 2-line segment, 3-line segment. So they are meeting on a specific point, and the lines which help them to meet on a specific point, these lines are known as diagonals. These are known as diagonals. So diagonal is a line segment that connects two non-adjacent vertices in polygon. Okay.
Yes, ma'am.
Now we have to write the definition and the example on your notebook. Okay.
Yes.
I will write here. You have to copy and you have to speak after me. Okay.
Okay, ma'am.
Diagonals. If you are able to understand the 2D, 3D shapes, polygons, diagonals, quadrilateral, then you are much easy, and that thing will become much easier for you to draw the graphs of these. Okay.
Yes.
Okay. Now we have to write the definition. Diagonal is a line segment. A diagonal.
It's a line segment.
Very good. A diagonal
It's a line segment.
is a line segment that connects
That
connects
connects
two non-adjacent, mean the point that are not adjacent with each other. They have the space, they have the distance between them. Okay. Connects
Okay.
two adjacent non-adjacent
two
non-adjacent vertices
vertices
of polygon. Okay.
of polygon.
Yes. Okay.
Yes, ma'am.
Okay. Now we will move to your textbook. Here we have the few examples. Okay, how we can draw the diagonals. For example, if we have hexagon, pentagon, octagon, you just have to meet all the corner points of them. Okay. Okay, if I draw here the picture of which one? Okay, I choose the octagon. Okay, octagon. So here I have to draw the octagon, mean 8 sides. 1, 2, 3, 4, 5, 6. No, not the correct diagram. That is like 1, 2, 3, 4, 5, 6, 7. That is 1, 2, 3, 4, 5, 6, 7, 8. Okay. I am not good at drawing.
Quadrilateral.
Yes, quadrilateral. This is the first one, and this is the second one. 1, 2, 3, and yes, we have the octagon like. Here. 1, 2, 3, 4, 5. Okay.
Get right.
1, 2, 3, 4, 5, 6, 7. Oh my god, I am very bad at drawing. I can't draw that. Okay, can you draw the octagon? I am unable to draw that. Octagon. Like this. Oh.
Yeah, I will try opening it.
I hope just like this. 1, 2, 3, 4, 5, 6. That is the hexagon.
Yeah, it's right.
Okay, just we have to, for example, if I just draw this hexagon like this, there's a diamond shape, like this. Okay, so we have this corner points, vertices of the hexagon. Okay, I just have to meet non two adjacent point with each other, just like this.
Okay, ma'am.
Just like this, that will be point with in front of its non-adjacent point, it will meet from its opposite side, and this is its opposite side. So this is the point where every point meets, is known as the diagonal, which connects, which build the bridge between two non-adjacent points. So this is the simple diagram of a diagonals, how we can draw the diagonals. Okay.
Yes, ma'am.
Okay, so the next we have the question. Can you name the diagonals in each of the line above figures? Is PQ a diagonal? What about LN? You already know what we mean by interior and exterior of a closed figure. For example, if we have to draw the diagonals lines in the non-adjacent point, we must have to give name to them. Okay, we have to give name to them. For example, this point meets this one, then this will be L and N. Okay.
Yes, ma'am.
For example, if this one is P and Q, then this one will be the PQ diagonal line. Okay, you must have to give the name to that lines you have drawn in the diagonal. Okay, so this is an interior and exterior. For example, if we have any figure, for example, this is a figure which is colored like inside, that is known as interior. The color is inside the figure. The color is inside the figure, that is interior. Okay, the color that will be outside the figure. For example, this is the figure, the color is here, the color is here. Now this is the exterior and this one is the interior. Okay.
Yes, ma'am.
Yes, good. Okay, next, the interior has boundary. Does the exterior have a boundary? Discuss with your friend. Interior has a boundary. Now this is a question. The interior has a boundary. Does the exterior have a boundary?
No.
No, because interior is enclosed figure, the closed, and the color is inside them, and exterior has outside.
Open.
Yes. One minute. Exterior boundary. This is the edge of the shape that separates the inside from the outside. That is the interior boundary. In exterior, this is also the same edge of the shape. The boundary is a concept that applies to the perimeter. I think the exterior do have a boundary. For example, this is the interior. They have this boundary. They have the color just inside the boundary. In exterior, they do have the boundary, but the color is outside the boundary. Both have the boundary. Okay.
Okay.
Yes. Okay, convex and concave polygons. This is the next level question. What is convex and concave polygons? Now this is a group. They distinguish the group. For example, if you are going to study about the shapes of the polygons, anything that is closed with a straight line. Repeat after me. Anything that is closed with a straight line, that will be counted as convex polygon. This is the shape, regular shapes, proper shapes, closed shapes. Okay, but in convex there is a closed curve, but it's not with a straight line. That are the curves. Okay.
Yes, ma'am.
So, can you find these types of polygons different from one another? Yes, we do. Polygons that are convex have no portions of their diagonals in their exteriors. Is this true with concave polygons? Study the figures given, then try to describe in your own words what we mean by the convex polygon and what we mean by the concave polygon. Give 2 rough sketches of each kind in our work. In this class, we will dealing with the convex polygons only. In the class, you will only able to study about the convex polygons. Now, can you explain what is convex polygons?
A convex polygon has closed straight lines. It has closed vertices. They
Yes.
have outward points. Example: triangle
Yes.
and a square.
Okay, if you have to tell me how you can define that square and triangle belong to the convex polygon.
They have outward.
Yes, they have outward corners. They have the outward vertices. Okay, what thing make different concave from convex? Which point?
It has one side that bends inward.
Like the example of
Arrow.
arrow. Very good. Now you have to look on your book. Polygons that are, we have the few questions here. It is true with the concave polygons. We have that is the true. Study the figures given, that is the convex, that are the concave. Then try to describe in your own words what we mean by the convex polygon and what we mean by the concave polygon. We have the two rough sketches of each kind, so we are able to understand this. Okay. Now regular and irregular polygons. Now define regular and irregular polygons. Regular and irregular polygons. A regular polygon is both equiangular and equilateral. A regular polygon, it's mean that they are equiangular. It's mean that if we have to draw the picture that has the equal angle in the whole diagram, in the whole shape, and that's mean that equilateral, each equal with each other. For example, a square has the sides of equal length and angles of equal measure. Hence, it is a regular polygon. A rectangle is equiangular but not equilateral. A rectangle, because it has two sides that are equal. Two sides are equal with each other, and other two sides are equal each other. The four sides are not equal with each other. Okay, but not equilateral. Is a rectangle a regular polygon? Is an equilateral triangle a regular polygon? Okay. Now we have to get the idea from the picture. Next one. Okay, now we have to get the idea about the regular and irregular polygons. So we will start from the regular polygons. The pictures that are equal with sides and equal with angles, that are known as regular polygons. Regular polygons. Okay, you have to write the point here. Regular polygons means any diagram, any shape, repeat after me, any shape,
Regular polygons.
any shape that has same angle, same not equal.
Any shape that has
Equal angles and same sides. For example, square. Square. Yes, square. Square has the same sides.
Yes.
And square has the same angle. What is the angle of square on each side?
90.
Very good. 90 here, 90 here, here 90, here is also, and these sides are all equal with each other. This is the best example, square as a regular polygon. Okay. Another example do we have? A triangle, which is get the name of triangle, but it is a specific name which belong to the triangle category, which is known as a regular polygon. Isosceles triangle. Which one?
Isosceles
Isosceles triangle.
Isosceles triangle.
Yes, isosceles triangle has Isosceles triangle has?
Equal side.
Yes. Equal side and equal angles.
Okay, ma'am.
Okay, this is a triangle simply like drawn has like this, equal with each side. You have to use the scale, okay? Here.
Yes.
Here is the same angle, here is the same angle, here is also the same angle and the equal sides. Okay?
Okay.
Okay, isosceles.
Isosceles.
SOSCELES. Isosceles triangle.
Triangle.
Yes. Isosceles triangle. And we also got pictures. We have to get the concept of equiangular and equilateral. Okay.
Okay, ma'am.
So basically, this is equilateral and equiangular. Okay. Equilateral means which have the same sides. Very good. Same sides. And equiangular means?
Same angle.
Very good. Equiangular,
Same angle.
same angles. Same angles. Okay. So square is a equilateral and equiangular, and isosceles triangle is also a equilateral.
Equilateral and equiangle.
Very good. Equiangular.
Side.
Regular and irregular polygons. Firstly, Sukana, can you tell me what is polygon?
Yes, ma'am. A polygon is a two-dimensional figure.
Figures that are plain,
Straight.
flat surface. Yes, that are in a straight lines, that are in a closed shape with the closed curves. Okay. So, what shapes and what things makes a regular polygon, and what shapes and what things makes a irregular polygon?
The triangle, quadrilateral, pentagon make regular polygons. Circle, cone.
Triangle. You told me that triangle is a regular polygon. How a triangle, and which triangle is a regular polygon? Isosceles triangle. Very good. And a square. Why the isosceles and the square are the regular polygons? Is there any specific thing about that? Any important point which makes a regular point? Because
they have closed line.
no, we
vertices.
also have a
They have
rectangular.
outward.
We also have a rectangular, which is a straight line, which has a straight
They all
line. They all
They
are.
have same measurement.
Yes, they are in same measurement.
Same measurement.
Yes, they are equilateral and they are equiangular. Equilateral means they have the same sides in same length. Each line is equal in length with each other, and equiangular means every corner, every edges has the same angle. That's why these things makes a regular polygons. Okay. So a regular polygon is both equiangular, and we have done with this. Now on the next page, these are the few shapes which are not polygons. Okay, here we have a rectangular polygons. Which one is 1 2 3 4 5, which is pentagon, and 1 2 3 4 5 6, which is hexagon, because every angle and every side is equal in measurement, and that is a regular polygon. And the polygons that are not regular, because they have a different angles, different in length, Okay, so there is a sign we use, double line or simple line indicates the segments of equal length. Okay, if we have a same length in whole shape, then we can use a single line to represent, or maybe double line. If we have a two different length of the straight lines, then we have to use the double and the single separately to show them. Okay,
Okay, ma'am.
is there a triangle that is equilateral? Now this is the question. Is there a triangle that is equilateral but not equiangular? Why? Why triangle is equilateral but not equiangular?
Um,
They are telling, they are asking a question that is there any triangle that is equilateral but not equiangular?
yes.
No, we don't have any, because
Now we have equilateral triangle.
we have the triangle that is equilateral and equiangular, but we don't have any triangle which is same in the side but different in the angle. No. Why? Because there is no triangle that is equilateral but not equiangular. If we have a triangle which has the same angle and that triangle is not in the same line, that is a very difficult thing. For example, now this is the screen I have. Okay, is my screen visible to you? Whiteboard.
Yes, ma'am.
Yes, if I have a triangle like this, okay,
Yes.
this is not equilateral because every side is different. These two are similar with each other, but this one is different. This is equiangular because the here is angle is different, here is angle different, here is angle different, and the sides are also different. Okay, so firstly we have to get the information about the equilateral triangle. Definition: an equilateral triangle is a triangle where all the three sides are equal length. For example, this is a triangle which is equilateral. Why this is equilateral? Because all the sides are, you don't have to write anything, I will tell you which we have, which thing is will be written. Okay, you just have to listen to me. Okay, what is equilateral? Means the same sides of any shape, any triangle. And equiangular, in any equilateral triangle, the quantity of the sides ensure that the three angles are also equal. If there is a triangle which is equilateral with the same side but does not have a different angle, that such triangle does not exist. Okay, why? Sum of angles in the triangle, equal side implies equal angles. Equilateral because whenever you have to sum the angles, all the angles will be contributed and we have the one angle of a triangle. Okay,
Okay.
an equilateral triangle is always equiangular because the property of having all the sides equal automatically ensures that all the angles are equal. Okay, if you are going to say to me that if we have a triangle which has equal sides but angles are different, that is not technically possible. Why? If the sides are all equal, for example, if I give a triangle which sides are equal, does this sense make that
No.
the angles will be different? Angles should be same because the lines are the same. Okay, so there is that such kind of triangle doesn't exist. Okay.
Okay.
Okay, good. Now we have to move to the next question. Angle sum property. For example, if we have any shape, basically we just have to calculate the angles of triangles, square, possibly square, but square is just another case. Okay, we just have to calculate the angles of triangle. That is a compulsory question. Okay, angle sum property. Do you remember the angle sum property of triangle? Have you done this topic before?
When we have done it, but not fully.
Okay, the sum of the measures of the three angles of a triangle is 180. If we have any triangle, okay, that is isosceles, that is a scalene triangle, any triangle, the sum of all three angles should be
180.
180. Very good. For example, this is a triangle which triangle is this? Can you name the triangle?
Scale.
No, this one is right angle triangle. This one is right angle triangle. This one is right angle triangle because angle here is
Right.
90. Angle is 90. Is it? Angle is 90. Now here we have an isosceles triangle. When we add each angle, that will be, I guess, 45, 40. Here we have 45, 45. Here we have, I guess, 60 something. Then we have the sum, which is 180. Okay.
Okay, ma'am.
And at last we have this kind of scalene triangle, just like this, which is also the sum of 180. Every triangle, rather any shape, any size, the sum of all three angles will be 180. And how we can add these sums? That is the critical question. Okay. Before going to the next topic, we have to write the few things about the regular, irregular polygons. Have we done this topic in the previous class?
Regular, ma'am, we wrote about polygons, but
Okay.
that not
We don't have.
regular.
Okay. So today we have to write about the regular and
Ma'am, we
irregular.
wrote about regular, but not irregular.
Okay, today we have to do the irregular polygons. Okay, just start writing after the regular, irregular polygons. Okay, irregular polygons.
Yes, ma'am.
Okay. So the definition of irregular polygon is a regular polygon has all the sides of same length and all. No, this is a regular. We have to do the irregular.